Grab ordinary table salt and a sheet of aluminum foil. Mixing these two everyday kitchen items generates actual physical heat. This begs an obvious question. If creating warmth is this accessible, why isn't it taught in every basic survival guide? The reason comes down to a chemical process that defies patenting, a lucrative energy sector that invested heavily to keep you in the dark, and 23 state governments that have actually outlawed the practice. Believe it or not, aluminum was not always viewed as disposable trash. Back in the mid-1800s, a single ounce carried a price tag of nearly $5, making it significantly more valuable than silver. It was highly sought after by wealthy industrialists and jewelry makers as a prestigious luxury. Advertisers of the Victorian era boasted about its brilliance, and presenting someone with a piece of aluminum was seen as far more extravagant than offering them gold. That exclusivity vanished in 1886 thanks to the Hall-Héroult method. Suddenly, using electricity, massive quantities of aluminum could be extracted from ore at a fraction of the cost. Within 4 years, its value plummeted from a luxury premium to a mere 30 cents a kilogram. What was once fiercely guarded in the vaults of the rich was now being churned out in massive rolls for bakeries and manufacturing plants. Fast forward a bit, and Reynolds Metals launched the very first continuous roll of household aluminum foil, utilizing a patented technique to flatten the metal to 1/1000th of an inch. By 1910, Reynolds Wrap hit the market, transforming a former precious metal into an everyday necessity. The U.S. Department of Agriculture even started touting its brilliance for keeping food fresh and retaining heat. Come the 1920s, it was the universal standard for wrapping up meals and lining baking sheets. Today, looking at a crumpled wad of foil, we completely overlook the immense scientific effort it took to engineer something we now consider so boring and ordinary. Yet, this shift from royal treasure to everyday trash conceals a fascinating secret. Despite its cheap status, the raw chemical power held within each sheet never actually vanished. It is merely lying dormant, trapped behind a microscopic wall that keeps its true capabilities completely hidden from view. The instant a sheet of aluminum is manufactured, it rapidly develops an invisible seal. It reacts so quickly with the air that it creates a uniform shield of aluminum oxide just a few nanometers thick. We are talking about a barrier maybe 15 atoms deep, way thinner than the ridges of your fingerprint, but incredibly tough. This is a natural, self-repairing skin. If you scratch the foil, a new oxide layer forms in a matter of microseconds. This impressive resilience is exactly why your kitchen foil doesn't dissolve when it touches wet leftovers or acidic foods like lemon juice. It safely bottles up the intense energy of the pure metal beneath it, energy that used to be incredibly expensive to harness. More importantly, this invisible shield prevents a wad of foil from instantly boiling or combusting when you toss it into the sink. The oxide armor withstands nearly all chemical interference, keeping the reactive potential locked away securely. Only a very specific set of elements can penetrate it, and without the proper catalyst, it is an incredibly slow process. So, to tap into this promise of free heat, you have to find a way to pick a lock you can't even see using an incredibly basic tool. Ordinary salt, a substance so basic we barely notice it in our meals, happens to be the exact key needed to unleash aluminum's dormant power. The fascinating part happens down at the atomic scale. When you dissolve regular sodium chloride in water, it bathes the crumpled foil in a relentless wave of chloride ions. These aggressive ions burrow straight into that invisible oxide armor, actively dismantling the protective layer that usually keeps the metal quiet. As soon as a single ion punctures the shield, it carves out a microscopic crater, throwing the naked aluminum into direct contact with the water, which sparks an instantaneous reaction. You'll immediately see hydrogen bubbles fizzing to the surface while the liquid's temperature quickly spikes. In a standard test, dropping a 2-inch piece of foil into a saline solution can drive the heat up by 10 degrees Celsius in under 30 seconds. This isn't an illusion. Calorimetry tests verify that a mere gram of aluminum unleashes roughly 15 kilojoules of thermal energy, which is plenty to make a cup of water noticeably warm. However, this isn't a limitless source. Once the aluminum degrades and the oxide layer patches itself up, the entire process grinds to a halt. While it might seem like perpetual warmth, it's actually a finite burst of chemical power unleashed by an incredibly ordinary, unbranded catalyst. The fizzing, the heat, and that distinct metallic scent all prove a genuine physical change is taking place, even if it isn't perpetual motion. It is a sudden surge of power from supplies so mundane we don't even consider them technology. While the science is clear, the implications are far more compelling. Sometimes the most game-changing discovery isn't a shiny new invention at all. It is a basic pantry item subtly upending the rules of who gets to control our energy. Generating warmth without any obvious fuel source feels like an absolute glitch in the system. Combining two of the absolute cheapest, most unexciting grocery store items to create heat defies our modern expectations. There are no burning flames, electrical cords, or branded fuel cans, just a bubbling sound, rising heat, and the eerie realization that a significant reaction is taking place right under the surface. We have been conditioned to associate heat with purchased fuel like propane cylinders, natural gas lines, or stacks of chopped wood. Every single one of those requires a financial transaction and a distributor. So, when a balled-up piece of foil floating in salt water can heat a mug by 10 degrees in half a minute, it feels like the rules have been rewritten. Sure, a kilogram of propane contains almost 100 times the absolute energy of foil, but this chemical trick relies entirely on kitchen leftovers and table salt. The appeal of this free heat isn't actually about discovering an endless power source. It is about the sheer exhilaration of cutting out the gatekeepers and uncovering a hidden backdoor method for comfort and survival. That liberating feeling of independence, of outsmarting the established grid, elevates this from a neat party trick to a profound act of autonomy. And to massive corporations, whose entire business model relies on selling you continuous fuel refills, this invisible reaction is a massive threat they simply cannot brush aside. Patent offices are completely familiar with the combination of foil, salt, and water, but when those applications arrive, there is absolutely nothing new to approve. Anyone trying to claim ownership of this exact reaction hits a dead end because the chemical process belongs entirely to the public domain. The materials are universally available staples, and the underlying science is as classic as a beginner chemistry textbook. The only patents successfully filed are for the clever external packaging or specific containers, not the heat-generating reaction itself. In fact, back in 2018, one examiner explicitly dismissed an aluminum salt application as a textbook example of prior art. This means absolutely no corporation can monopolize it, which is an absolute nightmare scenario for commercial fuel trade groups. Consequently, over the past decade, lobbying organizations representing the natural gas and propane industries have funneled upwards of $8 million into regional state campaigns, not to patent the science, but to legally restrict it. Their filings intentionally avoid mentioning salt and foil directly, instead targeting unregistered metal fuel heaters to essentially push do-it-yourself solutions entirely off the market. If you can't own the science through patents, your next best weapon is policy, shifting the battleground from the laboratory straight to the legislature. Across 23 states, generating your own homemade heat has caught the attention of politicians and fire marshals. The new statutes might not explicitly name grocery store foil, but their language is unmistakable. They have enacted strict bans on unapproved chemical heaters, forbidden metal fuel reactions, and introduced civil penalties for any device combining aluminum with halide salts. States like Texas, New York, and California all draw their regulatory lines around the exact same risk. That risk is the uncontrolled release of highly explosive invisible hydrogen gas in residential garages and kitchens by unpatented homemade devices, and these enforcements aren't just theoretical. Since 2022, fire officials from Tennessee to Colorado have logged dozens of incidents, issuing fines, mandating recalls, and even pursuing criminal prosecutions when these DIY heating rigs failed safety tests or caused minor explosions. During a county hearing in 2024, a fire marshal frankly admitted that the actual chemistry isn't what scares them. What terrifies them is the reality that literally anyone can replicate this process anywhere, using items they already have lying around the house. These patchwork bans have successfully walled off this once clever loophole, ironically enforced by the very same authorities who used to recommend keeping aluminum foil in emergency survival kits. Now, mere curiosity is viewed as a massive legal liability, and the freedom promised by simple kitchen chemistry is officially labeled a fire hazard. The most accessible triggers are inevitably the ones authorities try to forbid first. Ultimately, the true threat isn't sodium chloride or Reynolds Wrap. The threat lies in the concept that something so wonderfully basic could completely sidestep massive, established industries. That is exactly why this story continues to circulate, not just as a neat survival hack, but as an act of quiet rebellion. Sometimes the simplest, most everyday items are the most difficult forces to outlaw.